Hi guys, welcome to my tutorial for week 1, Introduction, Unit and Dimension. Alright, so without further ado, let's go straight to times page. So now you're looking at our times page for air conditioning and refrigeration engineering. So I need you to scroll down on the tutorial and answer section. Okay, so as you can see, week 1, both questions, the first one there, and the answers are unhide or not hidden, but the rest are hidden until the weeks are properly opened. Okay, so if you take a look on the first link there, it will give you around you have to forgive my voice because I'm currently having sore throat. 8 questions, yeah? 1, 2, 3, 4, 5, 6, 7, 8. Alright. However, if you go to our answers there, let me click on the answers. The answer only discuss question 5, 6, 7, and 8. Alright. Now, I will need you guys to open the question, both questions and answers on any of your devices while we discuss the questions together. Alright, so to do that, I will go to my PDF Expert app and go to the question. So I'm going to use a blue ink here. What I would like you guys to do is the first question until the 4th question. Alright, very simple. Question 1, air velocity can be expressed in question mark. Right, so A, B, C, D. Number 2, what system removes particulates from air? You can find this answer in our lecture note. Number 3, what is the function of dehumidifier? Also in our lecture note. And please use the quiz link on times. In that link, you will answer tutorial questions 1, 2, and 3 as attendance submission. Fail to do the quiz, meaning you are absent from both lecture and tutorials. Now, you need a few things here. Let's go back to our times page and go to the scheme of work and etc. section. Go to the HVAC conversion factors, click on that, and you will have a PDF with conversion factors there. We need this one as well, or you can also use Google Conversion if you like. So I'm going to need these two apps together. Alright, let's go for the first question. Here it's written 2.1, but on the question is actually question 5. Alright, let's go and read the question. A pump develops a total heat of 50 feet of water under a given operating condition. What pressure is the pump developing in SI unit? So that is the question. Here you will have, let me go back and you see it is 50 feet. Now, again, I would like to express most of air conditioning or HVAC system. It runs in not SI unit, but in English unit. Sometimes I'll ask you in English, sometimes I ask you in SI unit. In the previous semesters, I changed all the questions in the final exams, in the receipt exams and tests all in English unit to reduce confusions, right? And also conversions factor, right? However, this is to convert English to SI unit. Now, there's answer given there as well, but let's go and do this question together. First of all, we need HP, the height of pressure of water. It is given as 50 feet. Now here, feet need to be changed into meter. To do this, the conversion is 1 meter to feet is around 0.348 feet. Yeah, 1 meter is equals to 0.3048 feet. Right, so simply 50 times 0.3048 meter per feet, you get 15.2 meter, whereby you can cancel the feet and M will be left there, 15.2 meter. So rho GH is the pressure for the depth under liquid, right? So you have H like this. The deeper you go inside water or any liquid, the higher the pressure, right? So delta P is given by rho G and H. And the equation is given as rho GH. This section is for the H. Undo. This section is for our rho, or the density of water. And this section is for the gravity, right? So now you can see the height is given as 15.2 meter divided by 1000 PA kPa, because we want to change delta P from Pascal to kilopascal, right? So this kilogram can be cancelled. Let me erase this. One more time. Kilogram can be cancelled with this, and meter can be cancelled this and left 2, and Newton meter squared is, yes you guys, is Pascal, and this is to change unit from Pascal to kilopascal, and the answer is 149 kilopascal. Good. Now question 2. Question 2 says, make the following volume and mass fraction into SI unit. The first question is, water flowing at an average velocity 2 meter per second in nominal 2.5 inch of the diameter of a pipe, and the pipe is type L copper tubing, right? So to do this, the answer is given there as well. Look at the answer there. Question A, 2A, let's see. Water pressure is given by rho W, 1000 kilogram per meter cube, right? And here, V dot, let me increase the size there. V dot stands for volumetric flow rate. And here is in the term of meter cube per second. That is volumetric flow rate. In if I'm not mistaken, in fluid mechanics, it is V dot. In some cases, they use Q, right? Q. But Q is not to be confused with thermodynamics, where Q is thermal capacity of a system. So here we use V dot equals to V bar, and A is the diameter of the pipe, and this is a circular pipe. So therefore is, I think it's pi r squared over 4, right? That's why you have this. Okay, so let me clear that up. Alright, clear this up. Now, 2 comes from this 2 meter per second. There, right? And our 2 inch, you can see here, is our diameter. There, 2.5 inch. Convert to millimeter. You can use online conversion. What is inch to millimeter? And you get 2.5 inch is equals to 62.61 millimeter. So that is why it is around 62.61 times 10 to the power of negative 3 meter. And that is why the answer is such like that, as you can see from my arrow there. Right, so let me clear this back up. Maybe this one as well. Okay, so put in 2 times pi times 62.61 times 10 to the power of negative 3. We have to square them because it's pi r squared over 4, right? And the answer is 6.15 times 10 to the power of negative 3 meter cube per second. And that is volumetric flow rate. How many cube of water move or flow in 1 second of time? That is why you get this, right? Meter cube per second. Now, since we are talking about mass fraction also means the m dot or mass flow rate given by the unit kilogram per second. To do this, you all know already in fluid mechanics, m dot for the mass flow rate equals to rho, v, and a. Since VA is already calculated, which is this one, the volumetric flow rate, rho times V dot. So this one is times 10 to the power of negative 3. As we know, our rho should be 1000. So you just cancel them out and you get yourself 6.15 kilogram per second, which is this answer. Right. Let's go for B. The standard air, just now is water, standard air, flowing at average velocity 4 meter per second in a 0.3 meter inside diameter duct. Right, so that means the duct have a thickness, certain thickness, but we don't care about the thickness. Let me draw that out. And the one here is around 0.3 meter in the as the diameter. Alright, so let's clear this. Okay, to do that, look at B. Air is given as raw air. So just now water is 1000. It is now 1.273 kilogram per meter cube, where V dot is given as the same, V bar over A. You have 4 meter per second, and this is our diameter. And since our diameter is already in meter, you don't have to times 10 to the power of negative 3 like that. You don't have to do that. So you just times them. 4 times 5 times 0.3 squared over 4, you get 0.283 meter cube per second. Now, our m dot, our mass flow rate or mass fraction is rho v dot, which is 1.273 kilogram per meter cube times 0.283, which we have calculated previously, and all the answer will be given as 0.36 kilogram per second. That's how you get mass fraction or mass flow rate. Okay, now we go to question 7. Right, question 7 is given as air at 1 atmospheric pressure and 76 degrees Fahrenheit is flowing with a rate of 5000 CFM. CFM is also known as cubic, what is it? Cubic feet per minute. F3 to the power of 3, Ft to the power of 3 divided by minute, also known as CFM. At what rate, right? At what rate must energy be removed in BTU per hour? BTU stands for British Thermal Unit for 1 hour. How much it need to be removed from that flowing air to change the temperature from 76 to 58 degrees Fahrenheit. Now, we must assume that no humidification occurs. Like we have discussed in the lecture. If you haven't seen the lecture, please watch the lecture following with the slides accompanying with it. Humidification can increase heat absorption as we introduce water vapor or water droplets into the dry air. Right. To answer this, answer is already given there. So this is the diagram of air that move into a system. This can be a room, this can be a house, this can be a space. So it's as it is not specifically state what it is, we just assume it is a space. This red flowing arrow here is the Q dot. Q dot here is for the thermal energy. This is removed from the system in terms of BTU per H. Okay, so now there's a the air that goes in at this temperature, 76. When the air goes out, this is the temperature at 58.5, this 58 Fahrenheit. The velocity or the volumetric flow rate is 5,000 CFM. Alright, so to answer this, we will use the ideal gas equation, which is rho equals to PRT. Now, take a look at this. Here it says 1.47 times 144. Now, I'm going to switch to my conversion on times. As you can see here on the pressure section, 1 atmospheric pressure is equals to 14.6959 psia. Psia is also known as per square inch of air, also equals to 2116 pound. F stands for fluid over ft squared, right? That means pound fluid per feet squared, and also is 101,325 Newton meter per Newton meter squared, or also known as 101,325 Pascal. So we will take 1 atmospheric pressure at 14.7 psia. Right? Let's go back to our notes. 1.47 psia. Now here is 144. What is that 144 stands for? So what I need you to do is to change that psi into pound mass per feet cube, right? Since BTUH need pound per feet cube number or unit. Yeah, how do we do this? Go back to our Safari here, or Google Chrome, or whatever you have. Go to a Google section there and type, as you can see, I've already written there 14.7 psi to pound per feet cube. So I'm going to click there, and I like to use the first one there, convert-to.com. Right, 1 pound per cubic foot equals to 6.94 psi per 1,000 feet. So let's go down there and scroll to this section where you can enter amount. Since you have 144, so I'm going to type there 144 and go. And if you could scroll back up, you can see that it says 144 pounds per cubic foot is equals to 1,000 psi per 1,000 feet. Right? So we take this 1,000 psi and we try to convert it into 1.44. Since we know that our psi is we use the conversion lah, 1,000 psi equals to 144 pound. So when you times that like this, 1.7 times 144 for the conversion unit, and you get and you divide by 53.35, which is our constant at Fahrenheit, and also the last one would be the temperature, 76 plus, let me erase this, 460. 460 is like our Kelvin in SI unit. So this is Rankine, right? Rankine. So you need to change 76 Fahrenheit into Rankine. That means you have to plus 460, and you divide and times them, and you get the answer 0.74 pound per feet square. So at some point, maybe you need to do a 1/4 ratio like this. So 1/4 is whatever you have here, and you 1/8, and you get 13.5 feet squared over pound. M stands for mass. But since we're not going to use that, we're just going to take this 0.074 pound per feet squared, and then we're going to bring over to the next section there to find how much Q is removed. This is first law of thermodynamics. I do believe you guys still remember from thermodynamics class. Q dot is equal to M dot Cp delta T. Alright, so our Cp here is 1. Right, Cp here is 1. You can see at the conversion unit there, Cp here is 1. Or maybe you can see from the textbooks, Cp is equals to 1. If it's not mentioned, that is equals to 1. If it's mentioned, that's equals to 1. So P is, which is calculated, 0.074 pound mass per feet cube, right? And this is our CFM, 5,000 cubic feet per minute. Since we need to change it to hour, we need to times with 60 minutes, and then you get hour. And here is our difference in temperature in Fahrenheit, 58 minus 76. You will get a negative value, like you can see there, negative 95,939 BTU per hour, since Q or heat is removed from the system. That is why you are lesser by 95,000 BTU per hour. That's why it is negative, as heat is removed from the system. Okay, let's go for final question. A chiller is to provide 12 tons of cooling to a chiller water stream. What must the flow rate through the chiller be in gallon per minute if temperature of the supply water is 46 degrees Fahrenheit and the temperature of water running to the chiller is 60 feet? Now, maybe some of you know what is a chiller. Maybe some of you don't. A chiller is, for example, if this is our building block, let's say block C, you use your centralized aircon and you bring the heat from this block to a chiller, and usually it's called a cooling tower or chiller. Usually we use water move through the to the chiller, and it will go, let's bring in red pen, it will go in and go out and go back to the room. I maybe use the wrong color there. So high temperature water will go to the cooling tower and cool water will go out from the cooling tower or chiller. Right, so here you can see that the condition is given as that go in and go out of the chiller like that. Alright, sorry, I should press this. Okay, it says there 12 ton. So 12 ton of cooling rate. 1 ton is equals to 12,000 BTU per hour, British thermal unit per hour, and therefore 12 ton is 12 times 1200, and or 12,000. Sorry, so you get 144,000 BTU per hour, just like our calculation in the previous section there, right? 144. Now we have our BTU there, 144,000 BTU per hour. You can see here our volume flow rate is V dot times gallon per minute, which is we don't know. And also our Q or rate heat remove in the chiller or the cooling tower is given as this, because you know how much is removed. It's negative 144,000. It must be negative because heat is removed. M dot is LBM per hour. Cp is 1 BTU per LBM or pound mass times to the power of Rankine, times Rankine, and T2 minus T1 is 46 minus 60, which is the temperature difference. Mass is given as 10,285.7 pound per hour. How do you find this? We will use the equation of delta minus Q, which is given there. You know what this is. You don't know what this is. You know what this is. You know what this is. So you will get your M like this. Very simple. Just a simple algebra. Once you get your M there, you will put it inside this. So you know that V dot is equals to M dot over rho, right? M dot over rho, because M is row V. So you just do a simple algebra, and you find your V dot. Since you know what is your M, and you also know what is your P here is a water. You must know that it is not 1000, that is SI unit. This is English unit. It's 62.43 pound mass per feet cube, and you get your answer as 16475. Right, 475. Now you must change it to gallon per minute. You can see here, feet cube is our volumetric for English unit, not meter cube, but feet cube. A meter cube is also can relate to liter, right? But for English unit, feet cube can relate to gallon. So 1 gallon is equal to 0.1337 feet cube. That's why you have it there. And you must change hour to minute. So what you need to do is you just times and divide what is needed, and you get your final answer to be 20.538 gallon per minute, which is required to remove heat from 60 degrees Fahrenheit to 40 degrees Fahrenheit. So that is our quick review of tutorial 1 for week 1. You can rewind this video again and again. If you have any question, you can send me a Times message, and I'll answer you as best and as fast as I can. Looking forward to see you guys in our next video. Bye.